back to daily LeetCode day 102. I know the timer is already going in the bottom right. Please ignore it. We are back once again. Yeah, I posted earlier last week or yesterday. I mentioned, yesterday I mentioned I was short on time, so we didn't really get to talk about the day 100. But the day 100 video, I promise, is going to come out. It'll be the first produced video on the channel, so it's gonna be kind of cringe. Bear with me. Also, thank you if you cringed on my day 100 video. Thank you for not saying it. So I watched it back and I cringed. So that I will never watch that video again. So yeah, it is what it is. But there was a lot of comments that came. A lot of people joined the Discord, so that was just awesome to see. But we have a comment from Kan Kunawat. Keep it up, man. Keep being you, man. Feel strong, man. W Human. Respect the hustle. Sub for the energy and the positivity. Replied for the humanity and the love. Bro, I feel like I have no personality. Me realize that what makes you anything. Dang, yo, this is a deep comment, man. Deep. Yeah, I don't know. I don't really know. Yeah, I mean, I don't really feel like I have one either. I think they have there's a phrase there's a phrase or a saying that they say. It's like only the man who wears many masks is confused as to which one is him, or something like that. And yeah, I think I feel like that all the time, because I think I have when I was younger, I noticed, even in 5th or 6th grade, I noticed every person, every group, my life was compartmentalized. Every group of people that I knew, every group of friends or interests or everything, it always felt like I had a different set of protocols, or I felt like I had a different person for each person. And when I was growing up, I said growing up like I'm really old, but who knows? When I was growing up, I always felt like, that I was some kind of scam or some kind of clown that would be able to switch costumes and switch masks at a moment's notice. And I wondered if that made me like a snake or deceitful. But I think later on, I think I was just I think that's just who I am. I think I'm just many people, and I think I thought I had to be. I think I'm just many different people. When I was younger, I think I felt either ashamed or guilty about that. So I thought I had to always be one person. But I think we're all just a bunch of different people, and maybe it's definitely hard to see all those pieces, especially in the day and age of even online. You see so many different people and so many different content creators, and everyone seems like they have a brand or a aesthetic. And I think it could definitely feel like everyone has something intangible that you don't have, because I feel that way. I don't really feel like I have a personality. So yeah, I'm not really certain. I think maybe it's just the internet. Maybe the internet makes us feel that way, or maybe the internet portrays something, because everyone wants an aesthetic. Maybe the internet feels like, because we don't have one that's easily brandable or quickly recognizable, that we lack one. But maybe we both have personalities, and we just I wonder if I asked the people around me who they thought I was, I wonder what they would say. So maybe we're fine. And yeah, this is a good question. Something to think about. Good things to think about. I think I'm gonna ruminate on this. I'll probably keep thinking about this. But maybe the people around us, if we're close to them and if we can trust them, maybe they know who we really are, or if we've been vulnerable enough to show them who we really are, maybe they know who we are. But yeah, this is deep, bro. I think the internet is just getting to us, man. Yeah, the internet is crazy, man. It's tangential, and I'm just gonna talk about it a little bit. Yeah, I always think it definitely. I think it's yeah. I really think social media and this stuff. It's tough, man. It really is. Like I personally feel like, and I mentioned this in the previous video. These the part before I start LeetCode, it's just a brain dump of stuff going on in my mind. But I always think it's just so hard to like be yourself. Like I wake up and I have 6 notifications to check. I check the notifications and then I'll browse an app. By the time browsing an app, I'll check Discord. Then I'll go through all my Discord notifications, and then I'll hop on another app. Then I'll spend so much time on Discord or app 1 that now app 3 has new notifications. So I spend more time on app 3. App 3 is done. I spent maybe an hour on that. Then app 1 and 2 have notifications again, or someone texted me. And maybe there's just not enough time to explore, like, there's just all these, I don't want to say that companies are insidious or anything like that. But I think there is always, like, a thing with, like, personal responsibility and, like, you know, being able to make our own choices. And it's definitely, the line is definitely becoming pretty thin. Whereas, like, you know, a lot of these apps are, like, incentivized to, they're pretty much racing to the bottom of the brainstem. And so now you're battling against your, like, animalistic tendencies, but in an intangible form. And yeah, it's just tough. So I think what they always say is, there's another phrase. What they say is like, I think they say that the disciplined are free and the undisciplined are slaves to passion and emotion. And that I always come back to that because it always makes me think that, yeah, there's also a choice of discipline there, but also the way these apps and things work now, it's like the line is really getting, like, really thin. So yeah, I think we just need time and space to explore ourselves, and maybe if we can take just a bit of a break from all this stuff, maybe we can find it. But I don't know. I'm just a regular dude trying to figure it out too, so I also feel like I need to become interesting. We should powwow about this. We should powwow about this while getting sturdy in the Discord at the same time. We'll just talk about it while we're getting sturdy. So, yeah, it's just really interesting. That is really interesting. Here is the Day 101 challenge. Write a quick select by hand. What is quick select? Day 101 challenge. But you know what? Challenge accepted. The time complexity for this, my estimated time complexity for this is n to the n. Or which is just, I guess that's just n squared. No, it's not. N to the n. No, that would be crazy. N to the n is crazy. Or isn't n to the n exponential time? I actually don't know. I'm going to say it's going to be n factorial. Inspiring. That's deep, man. Silicon stem libraries. I'm just trying to get like you, brother. Grind, grind, grind. Yo, Thomas, legendary, man. Day 4. Yo, Tom has been here since, like, day 20, man. Honestly, Tom's probably been going longer than I have. Technically, we've been going for, when I made my first LeetCode video, it was day 74. But I hadn't started recording yet. So it was day 100. It's day 100 technically on YouTube, but technically it's day 174. So that's always interesting. But for that first 74 days, I can't give away the secret sauce. This is for the 100 days of LeetCode. This is for the 100 days of LeetCode video. So yeah. Thank you so much for the comments, man. Just legendary humans, just trying to figure out what we're doing on this floating rock, bro. And I'm gonna say we were all created to solve LeetCode problems. Yes, we were. So we're gonna have to jump on that. I also realized, so that video will come out soon. I will try. I haven't recorded. I've never made a video like that before, so it is what it is. But we're just gonna jump into it, and then with day 102, I did 30 minutes yesterday, so we're gonna do an hour today. I don't want to get into the habit of making up for lost time and doing an hour and 30, just because there's like 3 more hours of studying to do. So Definitely got to work on the highest priority thing. But I do have an idea. I have an idea to make something, and I think it's going to be quite fire. So I'm going to start making it, and then maybe I'll release it on the channel. And yeah, who knows? I don't really have anywhere to release anything, so I think it'd also be cool just to document the journey. So that'll be cool, but we'll see. I'll make something. I think it's time. And yeah, the upskilling, I finally am learning enough where I think I'm getting close to like finally being able to like make something. Not really, but half of it I'll just figure out while I'm doing, which is okay. But yeah, I'm really excited about that. So yeah, I'm gonna start on that, and then we'll see how it goes. I have 3 ideas. Actually, I have 4 ideas queued up, and it makes me really excited because I'd really like to work on those. And yeah, I think a lot of the fire is in the journey, so I'm excited to have enough. I'm excited to get the chance to work through all the difficulty for all these things. And then at the end, we'll get our 1 day of pleasure. So that goes to show. Yeah, so we're just gonna jump into it. We have 4 problems lined up today. I forgot last time we were doing a problem called summary of ranges that I didn't come back and complete, but we can still do this. We can still do this problem today. I don't know why the dark mode isn't working. Okay, finally. Then I'll refresh, but you're gonna want to make sure to join the hyperbolic coding chamber. There are hundreds of thousands of people. I forgot to make my camera big like I usually do. There are hundreds of thousands of people joining the hyperbolic coding chamber every second. The number of requests being routed to their servers is going gangbusters. So you're going to want to join as soon as possible before we use up all the available space on our Discord EC2 instance. Okay? Because we're at the max capacity, we're at the max performance, CPU and memory performance that we can do. So you're going to want to join as soon as possible before, because they're going to have to get those new GPUs into those machines, and who knows when that'll be. So there might not be able to get into the Discord. So you're going to want to join. And yeah, we're just talking shop in there. So, and we're also going to have a special guest 2 weeks from now that's going to be announced, and you're going to want to be there for that. So so yeah, we're just going to jump into it. And yes, bro, we don't get any code completion with this. I don't want to do this one in light mode. I thought LeetCode had a dark mode. I thought it had a dark mode. And also I can't pause on OBS for some reason. Oh, this is really frustrating. I don't like light mode. But we'll just deal with it. Gotta stay focused. We'll just deal with it. But I have to fix this light mode thing. So we're gonna do an hour. Let's jump into it. I said I'd finish this other problem, so we're gonna do this one. So we have summary of ranges. You're given a sorted, unique integer array nums. Sorted, unique integer array. So it's sorted, and the integers are unique. A range A to B is the set of all integers from A to B inclusive. That's true. I think they call this interval notation. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. Smallest sorted list of ranges that cover all the numbers exactly. That is, each element of nums is covered by exactly one of the ranges, and there is no integer x such that x is in one of the ranges but not in nums. Each range A, comma B in the list should be output as A arrow B if A does not equal B, and A if A equals B. Right, so if we end our range, and our range ends where it starts, and we should print A, otherwise we should print A arrow B. So for example, we're given a sorted unique integer array here, and they want us to return the smallest sorted list of ranges that cover all the numbers in the array, and the range would be 0 to 2, which grabs this range, 4 to 5, which grabs this range, and 7, which is not included in 5's range. And I think the way we know that something is a part of a range is if the current number we're at, if the next number is 1 plus that current number, then it's part of the range. So 0 plus 1 is 1, which is the next number, so it's part of the range. And then we have this one. We have 0. We don't have a 1 here, so it starts a new range, 2 to 4, 6, 8 to 9. And nums.length can be empty. So we'll do this one in Ruby or TypeScript. We'll just do it in TypeScript, just because we're bouncing between the two. Summary ranges, so we know that values of nums are unique. And we know that one of the constraints, we know that the number nums.length can be empty because it can have 0 elements. So if that's the case, let me make this even bigger. Okay, it's a little too big now. And I'll turn on Vim. Oh, I guess what I could do is keep the screen small. I never realized that, and then you can just up the font size. Actually, that didn't even matter. So if the nums.length can be empty, then that means that our output presumably would be empty. We'll just make an assumption, right, that if nums.length equals 0, then we'll just return an empty array of strings. Otherwise, we want to do this range. We want to, actually solve the problem. So presumably we're going to be returning an array. Right? So we need some logic for that array. But I think the way we could do it, if we start our array of strings already, because we're going to have a transformation step, but we're going to have, if we start our array with the value that is in the front of the nums array, so our nums array will start with the value of 0. Then what we're going to do is iterate through the rest of the numbers in nums and update that last value in there if it is 1 plus the end. So what I mean by this is we're going to have an array. It's going to start with 0, and this is going to be an array of tuples, I think. This is what we're going to start with. Then we're going to iterate over rest of nums. And what we're going to do is say, okay, well, now the current number we're on is 1. So if our last element, right, which is a tuple, if it only has 1 element, just add the number, right? So we would just add 1. Because we're at 1 here, right? It has only 1 element in it, so we don't have to worry about replacing it. But now we're going to go to 2, right? The next iteration. Now that we have 2, we're going to say, okay, check the last element in the array, which is this tuple, and then check the last element in the tuple if its length is equal to 2. And we're going to check if this element plus 1 is equal to 2. Well, it is. So since it is, we're going to change this to 2, right? And then we're going to do the same thing again, right? We're going to go to 4. We're going to check if the last element in this tuple is plus 1 of 2. We add 2 to 1, we get 3. The number we're at is 4. So we're not going to do that. We're not going to update it. We're just going to add a new tuple with 4 in it. We're going to be at 5, right? We'll check if it's plus 1. It is, so we're going to add the tuple. Then we're going to go to 7. It's going to be of type 2, but we're not going to, 5 plus 1 gives us 6, which is not 7. So then we're just going to add 7. And then it'd be a transformation step, basically, where, so I'll remove this and just return an empty array for now. It's going to need to be a transformation step to basically turn this into this arrow syntax, which I'm sure we can combine later on. But like we said, we get the answers 0 to 2, 4 to 5, and 7. And this one, this case is basically the same as this one. There's nothing that's too different. So we can stub out the logic. Now we just need to turn this process that we came up with into a pseudocode and pseudocode into actual code. So what we would do there, we would need to if last element in R has length of 2. Update. Oh yeah, it has length of 2, right? Because our tuple would have a length of 2. And there's two cases there. The first case is if last num in tuple plus 1 equal to cur num, update last num in tuple. Now, if the last num in tuple plus 1 isn't equal to cur num, then we want to start a new range. Else start new range. Then we'll start a new range. I think we'll have one more case. Say if last num in tuple plus equals 1 equals cur num, right? Well, no, oh yeah. So we have another case, right, where we have if the last element in the array, this tuple, has length of 2, and what if it doesn't have a length of 2? Then the then that means it only has one element in it. So actually, I think this makes more sense if we swap these two cases. So we say if last num in tuple plus 1 equals cur num, right? So if we're at 1, if we restart this whole thing, right, our array would look like this. The last number in the tuple plus 1, right, 0 plus 1 gives us 1. The next number we have is 1. That's perfect, right? Now what we're going to diverge on is if that last element in the array has a length of 2, we want to update that last number. In the case where we already have 0 going to 1, right, we already have that number. We want to update it to 2 now. The other case will be last element in the array, right, doesn't have a length of 2, in which case you just add the number, you would get 1. And then our else out here, right, is if last num in tuple plus 1 does not equal cur num. For example, we have imagine our array, right, of values that we're processing is 1, or if it is 0 and then 5, we're going to say, hey, is 0 plus 1, which gives us 1, equal to 5? That's this line here. No, we just want to start a new range. And this we're going to change what we do here and just say add element to tuple. So I feel kind of confident about this. So say const r equals num sub 0. You want to iterate over the rest of numbers. So say let I equals 0, I is less than num's not length. to say if last num in tuple, get the last num in the tuple, we can just do last tuple. We can do last tuple by just doing r sub r dot length minus 1, and I said this would be an array of tuples, so we need to wrap this up and to get the last number in the tuple, you would do last tuple sub last tuple dot length minus 1, right, plus 1 if it equals cur num. Well, cur num is going to be, I'll make this slightly smaller, cur num is going to be equal to nums sub I. And then we're going to say, well, if last element in R has length of 2, and that's just last tuple, so we're going to say if last tuple dot length equals 2. Maybe this is a little bit hard to read. If else is a little bit hard to read. But we're going to update the last number in the tuple, so we'd say last tuple sub last tuple dot length minus 1 equals num sub I, and then in the other one we'll just say, make sure add element to tuple, we'll just say last tuples dot push nums sub I, and then here we'll just start a new range. Well, instead of doing last tuple dot push, we're just going to do r dot push a new tuple with nums sub I in it. Then we could return, we'll still return an empty array just because I want to see what we get for R to make sure that our range is correct. So let's just check it for 0 to 7 real quick. We're going to spend 15 minutes on this problem, but our array is going to start with 0 in it. Tuple, an array, our array is going to start with an array with the element 0 in it. Then we're going to iterate through the rest of nums.length. And this is a problem because we're starting at 0. We want to start at 1. So we're going to say your last tuple is going to be r sub r.length minus 1, which is going to be that tuple with 0 in it, right? If our tuple.length minus 1 plus 1 is equal to num sub I, which it would be, then now we're going to do something different. We can't actually squash this, but we're going to say, okay, well, is the tuple of length 2 or 1? It's of length 1, so we're just going to push the number. So we're going to have 0, 1. Go to the next iteration, we're going to be at 2. Last tuple is going to be that tuple with 0 and 1 in it. Is the last element in last tuple dot length minus 1 plus 1 equal to num sub I. 1 plus 1 does equal 2, and the length is already 2, so we're just going to take the last element, update it to be the new value 2. Go to the next one, we're going to go to 4, last tuple dot length minus 1, which is 2, plus 1 is 3, does not equal 4. So we're going to skip this and just do r dot push num sub I, which is going to be 4. 5 should end up with the same thing, and 7 should as well. So let's see if we get the right array. Line 41. So maybe we're missing a bracket. I think it's this. I want to push an array of the tuple on. Oh wait, no, this still doesn't. well, it should be lining up. We want a tuple to push on, and then we do num sub I. But it's on line 41. We don't even have. Oh wait, why are we missing the end of our function? I don't know how we lost that. So this, it says wrong, but this is the exact range we're looking for. Oh, so, oh no, I just turned it on. My LeetCode is like in like this weird inverted color. Okay. So now we just have to do the transformation step. So I think what we can just do, say const answer equals r dot map. We'll just say tuple, right? And we want to say I like to turn this into an array of strings. So actually we could just do reduce as well. Actually that wouldn't work because we need, so we'll just do map, and then we'll just say tuple.length equals 2, and we want to return, and it might just be easier to do if we just change the parameter to t. We'll return t sub 0 arrow. Is it $? I think it's $. T sub 1. Otherwise, we just want to return T sub 1, but as a string. And then what we can do is just return ans.join. String is not assignable to type string. Oh wait, they wanted us to return an array, so we actually don't have to do join. So we can just return the array. Oh, we got the right answer. We used arrow, a thick arrow. They wanted thin arrow. Try the test cases. Nice. So this is actually pretty slow, and I think if we removed the part where we do this map here, because the string could be pretty long, if you remove this part, I think it would be much faster. I think it would be much faster if we did that. I mean, it's technically still linear time because we're just going through the array of numbers once, but to get faster up here, we have an array which at worst case, every number would be interval list. So you just have an array of numbers in here where each is one separated from the other, which our array would just be linear space. So this would be linear time and linear space, I think. But I think we end up doing 2n because of this map part right here. T sub 0, T sub 1. So you know what? We will take it. Now I think we should compress this. I think we should compress it. Is there a way to roll this into what we're doing up here? Basically fill in the array. actually don't think I know a way to roll it up. If I drag the loop inside, if I build the array of array of ranges as I'm going through it, we end up with the problem that I could just replace the string when I do this update portion. I could just replace the character 2 here with, the character 1 here with 2, like what actually happens. Problem is, when we get multi-digit ranges, if I go from 0 to 100, if I just replace the last digit, it doesn't actually replace the number. So then I'd have to basically find where the arrow is, or regex, and swap the number out. But then I feel like that would be pretty slow. So yeah, it's unfortunate. It is unfortunate. In the end, I do feel like the way that the output is required for this problem is the part that's giving us an issue. If it wasn't an array, actually no. Thus we keep 2 indices representing the 2 boundaries of the current range. For each new element we check if it extends the current range. J plus 1 is less than nums.length, and nums j plus 1 is equal to gems j plus 1. Summary.add nums I plus I equals j plus 1. Yeah, this is interesting. Instead of keeping track of the last number, they keep going. And then as soon as it's not the same, num sub I, num sub j, in that means this is a really clever solution. That's a really clean. Oh wait, so I guess mine's is linear. I guess you're not counting the output. I guess mine's would be constant space as well then. I guess we're excluding the output. Well, no, mine's would be linear space because I have to do a transformation step and they don't have to. So that is pretty cool. That is really clever the way they solved that. That is pretty interesting. So then we have add digits. Given an integer num, repeatedly add all its digits until the result has only one digit. Given an integer num, repeatedly add all its digits until the result has only one digit and return it. So you have 38. 3 plus 8 equals 11, and then 1 plus 1 equals 2. Since 2 has only one digit, return it. A number can range from 0 to 2 to the 31 minus 1. Could you do it without any loop / recursion in constant time? Dang. I guess the way I would do this would be while loop style. And we would just say you'd have a number, you have the number 38, you could turn it into an array and just keep updating that array with the value. Or just keep summing up its digits. What we could do is say r equals, I actually don't know how you would turn a number to an array in Ruby. Num.toS So it looks like we can do 2s.split to get it as an array, and now the bindings aren't working. Num.2s.split to get into an array, and then what we want to say is while r.length does not equal 1. We'll do some work, and then when the result has only one digit, return it. So we would just return r sub 0.2i. Actually, you might not even need to do 2i. Do r sub 0. We'll do, if you do s dot split, and then dot map ampersand to get into an array of numbers. Yeah, so r.length does not equal 1. Sum the individual pieces. So to do that, we would just do 0 going up to r.length, and we just say I think I assume we could change this up. Okay, we could change this. Instead of doing R, we'll just say sum is equal to num. Then we'll say then here we could do while sum is greater than 10. I think we only get positive numbers. Then we'll say sum, and instead of doing this, we just return sum. And then now we just need the array to iterate over. So we say r equals sum dot 2s dot map ampersand 2I. And we'd say wouldn't even need the indexes. We just say r dot each num r dot each do num, and then we'd say sum equals 0, sum plus equal num. And so sum would equal 38 while sum is greater than 10, 38 is greater than 10. We would take sum, which is 38, map it to a string, and then an array, say 2s, right, dot split by empty space. So we turn it into a string, we split it, turn it into an array of strings, and then we map those strings to numbers, and then we set sum to 0, and then do r dot each do for each number, right? Sum plus equals 3, sum plus equals 8, we get 11. 11 is greater than 10. We map 11 to an array of numbers. We set sum equal to 0. We do r dot each do num. Sum plus equals num, which is 1, 1, and we should get 2. Oh yeah, greater than or equal to 10. I trolled. Yeah, I don't like that one. Well, that one took like 4.5 minutes. It was just figuring out how to do that. Operation here was a bit cumbersome. And then they have a follow-up. What's the time complexity on this? Time complexity, I wouldn't even know how to count this since the numbers change every single time. My best effort guess would be linear time, which is just really general. And it'd be constant space, since the space we use would just depend on the length of the number at the time. I guess at worst case, it wouldn't be constant space, since the array, at worst case, our number could be really, really long. But even then, the length of a number is kind of bounded, I think, because of how many bits you can use to store it. So I feel like our number, actually I would say it's constant space, just because our number only goes up to 2 to the 31, which would be signed. Well, actually it wouldn't. It would just be 2 to 31, which means our array at max has like our array would have at max like 12 characters. So I would say constant space as well. But how do you do it without any loop or recursion in constant time? It means there must be some math element to it. So if there's no loops, that means we can't do multiple bit shifting operations. So there's definitely a math to it. let's just take a ridiculous number. We could say if a number can be safely divided by an amount I think we might be able to figure out if we check out what the answer to 47 is, right? If you sum 47, you would get 11, and then from here you would get 2, which would now mean that you're good. So you'd return 2. Maybe not. So what I was thinking of was maybe there's a number you can divide it by, but I don't really know. So let's see. If I were asked the computer's so-called digital root logarithmic time solution is easy to write, the main question here is how to fit it to constant time. Math problems that have these math gotchas at the end, I'm not really excited about. But yeah, I don't really understand what they mean by digital root. Definitely didn't have a logarithmic time solution. 10. They're doing num plus equal. There's not even anything here. Num plus digital root plus equal num mod 10. If you did 38 mod 10, you'd get 8. And if digital root is greater than 9, num equals digital root. Digital root. Num divided by 10. 10 Num mod 10. Yeah, this one, I think our solution is good enough. I definitely wouldn't want to do this like as a legit problem. An ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return true if n is an ugly number. Bool is ugly. One has no prime factors. I don't know what a prime factor is. Its prime factors are limited to 2, 3, and 5. Given an integer n, return true if n is an ugly number. Equals 6, true, equals 2 times 3. I want to say that this one is just return true if n equals 1. And then the other one is that the bindings don't work right now. I keep having to do that. If n equals 1, and then we could say return true if n mod 2 equals 0 and n, or I guess n mod 2 equals 0 or n. Actually, I don't think this would work. I said whose prime factors are limited to 2, 3, and 5. So maybe we want and. N mod 3 equals 0 and n mod, what did they say? 5. How is it? Wait, this makes no sense. All of its prime factors. I think we have to figure out what a prime factor is, but I'm gonna guess it's not what I'm doing here. I was gonna take a guess with this. Yeah, this one, 14. No one knows what a prime factor is. Let me see if I can figure out what is a prime. Prime factor is a natural number other than 1 whose only factors are 1 and itself. Ah, I see. So they're saying an ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. I see. And 14 has a prime factor of 7 in it, which means it can't be, which means it's not an ugly number. So ugly numbers only support prime factors of 2, 3, and 5. And a prime factor is a number that's only divisible by 1 and itself. So another prime factor is 7 because it's only divisible by 1 and 7. So I think we need a method. My keyboard isn't working. Need method to generate prime factors. How could you generate all the prime factors? Is it just all the odd numbers? it's not all the odd numbers because 15 is not a prime factor and 15 is odd. Let me see. Generate. N is 1. Yeah, this one, I don't think we know how to generate all the prime factors for a number. Method to generate prime factors. If we knew how to generate... light mode is torture, man. We need a way to figure this out. Light mode is actual torture. I figured it out. What if we have an array called prime factors? Maybe not. Whose prime factors are limited. So only its prime factors. For example, 6. 6 is prime fact. 6 is also... Let me check. We can check this actually. So delete this and just do some testing. What if we did a number like 16? Is it a prime factors? For map you live in, it's a 2, 3, and 5. I don't understand how 6 is a prime factor though, because 6 and 5 are not compatible at all. Maybe they mean 2, 3, or 5. 2 or 3 or 5. This question has a lot of downvotes, so it could be that they mean or here. We can check actually. If I put in 9, nothing happened when I pushed the 9 key. But 9 is a prime factor. I guess it's limited to 3 because neither do 2 and 5 do not go into 9 at all. Now if I put 18 should not be, or by this definition of 2, 3, or 5, it should be a prime shouldn't be because it can also be a factor of 6. So I'm going to say false, and it's true. I think they don't want it to have any other prime factors, not any prime factor. We need a way of knowing if something is a prime factor. So it comes back to the same point where we need a method to generate prime factors. I have no idea how to generate a prime factor. We have 6 minutes. I'm going to see if I can do this one instead. Given the root of a binary search tree and a target value, return the value in the BST that is closest to target. So BST action. So we're given the root, which is 4, and a target value. We want to return the value in the BST that is closest to target. So in this problem, we're given this tree. Our target is 3.714. The value that's closest to it would be 4. I think that, well, they're given a BST, so they want us to use the BST for certain. Number of nodes in the tree is 1 to 10 to the 4. I think there's a solution to this that's linear time, but it doesn't use the BST at all. So I think what you could do is just have a function called get values. You would pass in root, you'd pass in an array, and then get values would just do it would just visit the entire tree basically. So we could just do we'll just say if node, and you could just do in order. We'll say r.push node dot val, and we can also pass in target. And if we pass in target, we can set the other value in the tuple would just be node. dot val minus target dot abs. And then we say get values node dot left target. And you could say r dot sort item a comma b. We could say a sub 1 minus b sub 1. You could return r sub 0. Maybe. Let's see. R sub 0 dot val. Is it dot value or dot val? Oh, no, it's r sub 0. Should be the first element sub 0. So this one works, but I think it's pretty ghetto. This is pretty ghetto. So we're not using the BST. So tomorrow we'll come back and we'll use the BST for this one. We'll use the BST for this one because this is linear time. Actually, it's not linear time. It's n log n time. Actually, my other version was n log n time. But there's a BST here, so there has to be a way to make certain... there has to be a way to make this log n time, because that's what you get with the BST. So there has to be a way to make this work. But yeah, we'll stop there for today. And yeah, I'll see the gang tomorrow.